So here we go with Chapter 8, specifically 8.1, Sequences and Series. So if you read this, you obviously know that we have a whole bunch of terms that we need to go ahead and define. The first one is a sequence. So a sequence is an ordered list of numbers. List of numbers. So 1, 5, 7, so on and so on, an ordered list of numbers. But these can either be infinite, so meaning that they can go on forever and ever, or they can be finite. So a finite sequence. And a finite sequence is a function, so our favorite term, so a function that has a limited number of terms. Of terms. And specifically about this, it's whose domain is the finite set of, so we're going to go ahead and we're going to list this here, 1, 2, 3, and so on until it gets to the nth term, meaning that it goes ahead and it stops somewhere out there. Sorry, that was a bad one. There we go. All right, so this, of course, is our domain here. But then we talked a little bit about terms. So it says a limited number of terms. And what happens here is that our term, let's switch to orange, our terms are the outputs or the range. So for us, we would have the output of this one, whatever it would be your first one. And then, of course, the output of this and the output of your third term or the output of your nth term. All right? So these are kind of all of our vocab that we're going to be using today. And the first thing that I'm going to ask you to do is I'm going to ask you to write the terms. So I'm going to give you a rule for a series, and this is going to look a little familiar. So, for example, f of n is equal to negative 2 to the power of n minus 1. And the thing that's interesting about this is that we're going to go ahead and we would have the first term. So we'd have our first term, our second term, and our third term, so on and so on. So let's go ahead and let's do this. So all you need to do is that you need to input, to find your first term, you input 1. So f negative 1, negative 2, 1 minus 1. Now we know that that is negative 2 to the 0 power. Anything to the 0 power is 1. Then same thing for our second term. You, of course, input 2. So negative 2 to the power of 2 minus 1, we know that that is negative 2. And our third term, here we go, and we know that that's negative 2 to the power of 2, which is actually a positive 4. So those are all of our first and second terms of this series, and we can keep going for this one. Now, sometimes series look a little bit different, and they're written with an A. And for those of you that have done CPM before, you might have seen this. So A sub n is equal to n plus 4. And it's the same type that we go ahead and we just replace n because n is what we're looking for to find our terms. So the first term, you simply just write A sub 1 is equal to, and then you input whatever term it is, 1 plus 4. So the first term is 5, a sub 2. Second term is 6, and then a sub 3. 3 plus 4. The third term is 7. So just a, oops, sorry there. So just a little bit on your notation is that you can either have it kind of in this function form over here, or of course you can have it in a and using an a and a sub there. So that's just a little bit in terms of writing some terms, and that's things that you guys have done before. Now, for the most part, what happens is that they will give you a series and you need to write the rule. So this a lot of part is also about just kind of figuring out patterns. Okay, so you can do this in a few different ways. It kind of depends on how you like to work with your brain. So I'm going to kind of put these down here in blue here. Number one, of course, that you have the option to plot some points. So if you're having a hard time kind of looking at the pattern and realizing what it kind of, you can look at what it's representing. You can plot points and kind of look for a shape. So whether it's linear or quadratic, exponential, you can go ahead and you can plot some points. You also have the option of just looking at the numbers. So looking at the series, at the sequence. Looking at the sequence and kind of figuring out from there what's the difference between them. Maybe there's a multiplier, and sometimes there's just different rules that we know. So such as we know a linear rule, we know a quadratic, things like that. Okay, so let's go ahead and let's look at some of these sequences. Example 1. The sequence that I'm going to start with is 3, 5, 7, and 9. Now that's always kind of good to note that sometimes there's different rules for these sequences when you're only given a certain amount. But what we can go ahead and we can start looking at this one. So I know I'm going to write this in sequence notation kind of here. I know that a sub 1 is equal to 3. And I know that a sub 2 is equal to 5. A sub, 3 is equal to 7. And the fourth term is 9. And some of you might have seen this already. We can start to see, hey, the difference between them is always 2. All right, so the difference between them is always 2, meaning that I know that this is linear. All right, this is a linear pattern going on. And if it's a linear pattern, I need to know my starting point, meaning that I need to know kind of this a sub 0 up here. And you can figure that out either way that you'd like, but we know that it's starting at 1. So it has a growth of 2, and it's starting at 1. Going back to Algebra 1, we know that my rule for this guy, so my rule is going to be a sub n is equal to 2n plus 1. And this is simply just a linear pattern here, but we wrote it in this sequence notation here with a sub n. Let's go ahead, let's try another one. Let's try 2, 5, 10, 17. Now, do me a favor here and kind of write this in your notation here. A sub 1 is equal to 2. A sub 2 is equal to 5. A sub 3 is equal to 10. a sub 4 is equal to 17. Okay, if you can figure it out, go ahead, hit pause, try it on your own. Okay, and you might be back with me. Now, just kind of looking at this pattern, you definitely see that it's not linear. So it's definitely not linear. And this is where kind of that discovery needs to happen here. You might see, if you wanted to go ahead and you could plot these points, that would be a really good option. So I'm going to say maybe plot. But some of you might have seen that these relations are growing in a certain way. And we can go ahead and we look at our pattern, and this one happens to be 1 plus 1. This one happens to be 4 plus 1, 9 plus 1, and 16 plus 1. And now that we know a lot about those numbers, we can go ahead and we can write ourselves a rule. So from this rule, we can state, okay, we're going to go ahead and we are going to square whatever is our term. So we're going to go ahead, we're going to square it. And then we're going to add 1 to that result. And this simply is my answer right here. That's my rule for this sequence.